everyone, today's objectives is graphing exponential models, some definitions and some informations. Just like every graph, every point on the table of value is an exponential graph. It's a solution to the equation. So any of those points that you see or any the line is connected is all part of infinite many points. This means every solution to the equation is on the graph of that equation. So that's same thing with every single graph we've done so far. So now the definition of an exponential function. An exponential function is a function whose equation can be put into the form f of x equals a times b to the x, where a does not equal to 0, b is greater than 0, but b is not equal to 1. And the reason for that is for 1, doesn't matter times how many times, it does not increase. And when you look at this function, it goes up very fast. So you have to have something that is either going up very fast or going down very fast. That's why it cannot be equal 0, because because it cannot equal to 1, and 1 times anything to the any power is still going to be 1. And then there's another thing that you guys probably have not heard. There's such a thing called a horizontal asymptote. The horizontal asymptote is the curve will always approach the x-axis as x approach either positive or negative infinity, but it will never cross the axis, as you will never be equal to 0. It will never be equal to 0. So it will get very, very, very close to 0, but it will never get to 0. All right. And then so could be positive and negative. And then as time goes on, I will explain a little bit more. So those are two very important definitions. Make sure you keep that in mind. So let's go on to look at the examples. On example number 1, so it says use the function y of x equals 3 times 2 to the x power. Now don't forget order of operation. So in this case, 2 to the x power has to go first, all right? Or if you have a TI 83 or 84, they will calculate this for you. To answer the following, use the pattern in the table to fill the rest of the output value, and B, we're gonna plot using this equation and plugging all the values. Please do A and B and we'll check your answers. Trying to fill in the table, I hope you guys can see the work I'm showing. And if you take a look, because it is gonna be -1, I'm putting the -1 in the equation 3 times 2 to the x power, which is look like this. And don't forget, when you have a negative exponent, you flip. That's a negative exponent. You flip and it become 2, become a half. And so it's 3 over 1 times 1/2. So that's 3 over 2. And same thing here, because that's looking to -2. Because that's a negative exponent, you flip over, and so you get 1/4, because 2 times 2 is 4. And so therefore it's 3 times 1/4, that's 3/4. Then you do 2 to the -3. -3, 2 to the -3 is actually 1 over 8. And then so when you do 3 times 1 over 8 is 3 over 8. And then so those are the points you're gonna plot your points. And then I'm gonna run out of space for 12 and 24, and that's okay. We are going to just go towards the direction. So in this case, the graphing 0, 3 is the easiest one to plot, and the next one is going to be 1 and 6, which is right here. And then you have 2 and 12. I just mark 2 more spaces. There's my 12. So that's to the right hand side. And to the left hand side, we are looking at -1 and 3 over 2, and that 3 over 2 is 1/2. So -1 and 1/2 right here. And then when you have 2, it's gonna be 3/4. So that's about 75% of the box. Then it's 3/8 is getting closer, and it's gonna get closer, and it's gonna get closer, and it's going to get closer. But no matter what, doesn't matter how you flip it, you will always be able to get a number. There's always going to be something smaller and smaller, but it will just keep on getting smaller. So as that keep going, if you can keep that thing in mind, C says as the input value become more and more negative, which is on this side, -4, it will get smaller. The output value gets smaller. The next one, will the output ever reach 0 in this direction of graph? No. The reason for that is because if you keep on plugging numbers in here, there's not going to have any exponent possibility this will be 0, because there's always a number that you can take it down to smallest fraction. So in this case, they will never reach 0 in this graph in this direction. Now the next one, as the input value become more and more positive, what will happen to the output? So if you're going towards the positive side, did you notice the value of the x going on towards looking at the y when x is positive is going up very fast. All right, so it will only get larger. The next question, would the output value ever reach 0 in this direction? Well, no. Value goes higher and higher. It will never reach 0, so no. So then the next question is asking, well, can you identify x-axis? Well, when you identify x-axis is when y equals 0. Well, in y will never equal 0 because you will never touch the x. You are looking for x when y equals 0. So there will be none. It will never touch the line. It will get very close to it, but it will never touch it because we talk about we will never get to 0. It will never be y equals 0 anywhere. Then the next one, find the y-intercept. That's when x equals 0, and that's right here. When x equals 0, then that's going to be 3. Identify horizontal asymptote. And the reason we are going to say y equals 0 is because if you look at this line, and if you look at the line that's going to be approaching, and that is what, if you have a line and you just keep going and going, it's going towards the y equals 0, but it will never touch it, and that is called an asymptote. The horizontal asymptote is this way. That's a horizontal asymptote. Where does that stop the line? That would never touch it, okay? And in this case, that's going to be y at 0 because it's this line right here. See, it will approach this line right here, but it will never cross it because it will never be able to get to the 0. So that's why the horizontal line is that way, and therefore it's going to be at 0. So that's example number 1. And then let's take a look at example number 2. Please try example number 2 and we will discuss all the questions asking. For example number 2, my values are as follow, and the graph is to your right, checking out the number. Some of you guys will probably worry that if you have a negative 3, you have a 32. And don't worry, we can just have the direction of, I think you guys have up to 8 that you can put in the graph, and just aiming towards that direction. Same thing with the decimals, 0.0625. I know you can't just keep on going smaller. It will still keep on having answer. If you plug in 7, it has a smaller answer. If you plug in 8, you have an even smaller answer. And 10, 11, 12, no matter what you're going to get, it's going to be smaller answer there still. But it's just going to get so closer. But think about this. When you have an iPad, you can always make it bigger. And you can always squeeze a little bit more stuff in between right there. So, you know, there's a little number theory says between any two numbers, you can always find another number. And this is one of those ideas. All right. So, going on answering the question, you should pretty much understand the question will be pretty much similar to the ones above. As the input value become more and more negative, input value getting very negative. So that's going this direction, going negative. What happened? Well, the value of the output gets very big, very large. Would the output ever reach 0 in this direction? Would it ever go down to here? No. So therefore, it's D. Then the next one, as the input value become more and more positive, right here, going towards positive, what happened to the output value? The output value just gets smaller, or you can look at right here. When it gets bigger, it gets smaller. And then same thing right here, you can look at if it gets more negative. If it gets more negative, the number gets bigger, both under the table or the graph. Then would the value ever reach 0 in this direction? It will absolutely not, because no matter what, it will only get smaller or only get bigger. So would the output value reach 0 in this direction? No. And then now they want you identify x-intercept. Well, because the line will never cross x-axis, there's no x-intercept. No x-intercept. Y-intercept is when you're on the y line. Well, when you are talking about y line, this is x and this is y. So where's the point they meet? Right here. There's your y-intercept right here. And identify y-intercept. That's 4. Identify horizontal asymptote. Horizontal asymptote is which line does it cross that the line will be approaching to but will never touch. Well, in this case, it will be this line right here. It will approach to this line, but it will never touch this line, and that line again is y equals 0. And 6.4, the base multiplier property. And the objectives is understand the sum of the base multiplier. What does it do to the equations? And understand that when you're looking at the 7 right here, this is called the base, okay? And the 3 is the exponent. And what happens when you are talking about the exponent? What does it do? So the base multiplier property, tells us when x increased by 1, which is right here, okay, the value of the y is multiplied by b. You are multiplying however many here, you multiply the base how many times. That's all. Base multiplier property. Example 1. Let's say the given function describes the relation between the price P, this is the price, of a product A, that's just whatever, and then the number of months of the product has been on the market, that's P, that's X. So in this case, this is the number of months, all right? This is the price. So now what I want you to do is do A, because you are going to just use the equation and fill out the chart. So for the example number 1, here are the answers. When you fill out the table, you plug in the number 0, 1, 2, 3, 4, 0, 1, 2, 3, and you get 100, 102, 104, and 106. And what type of function is described? Well, this is a linear function because it's y equals mx plus b. C. Explain the context of the problem. What the constant term 100 mean in the function of px equals 100 plus 2x. The 100 is the starting price of the product A, or the starting price of product A is 100. D. Explain the context of the problem. What is the constant coefficient of 2 means in the function of 100 plus 2x. There's the 2. 2 means every month the price of the product A goes up by $2. So in this case, it should only just be 2. And that's example number 1. Example number 2. Let's say the given function describes the relation between the price of the product B, P, and the number of months the product has been on the market, that's the X. So what happened to the Y as we increase X by 1? Well, Y will just have to take the initial value times 2. Every time you increase 1, you multiply by another 2, all right? And then go ahead, fill out the chart and answer some of the question. Let's see, do you think you get the same answer as I do? Here's what I have. What happened to y as we increase x by 1? In the equation, y equals 5 times 2x. If x increased by 1, then the answer will need to multiply by 2 again. So think about this. If this x goes in as 1, that's times 2. If this x goes in, 5 times 2 times 2. If this goes in as 3, it's 5 times 2 times 2 times 2. So therefore, it depends on how many x you get, as how many times you're going to multiply by 2. So if it goes up by 1, then that means you're going to go up, multiply by 2 again. And that's how I figure out the numbers right here. And there's, start with 5, goes up to 10, and then doubling and doubling, because 2 times. Then what the next question is asking, explain the context the 5 means in this problem. Well, the 5 means the beginning value of the product B before we have put anything else. So that's the beginning value. If 2 is equal to 0, which is 2 to the 0 power is 1. And if it's 1, it's 5 times 1. So that means within the 0 month, the product is already at $5. So then the next one goes on to, so that's going to be the beginning value. So D, explain the context what the 2 means. What 2 means the price goes up by 2 times each month goes by. All right. So because this, if you have x goes 1, that means 5 times 2. Again, if it's 2, that's 5 times 2 times 2. So since in this case it is what the base is going to be, 2 means the price goes up by 2 times. Okay, so it depends on how many of them here is going to be 2 times however many they want you to multiply. So 2 times each month. So if it goes up 1 time, you times 2. If it goes up another 1, you times 2 again. Times another one, it goes up another 1, you times 2 again. So that is going to be your your answer for example number 2. All right, next thing, make sure you read through it. Base multiplier property. For an exponential function of the form f of x equals a times b to the x, if the value of explanatory variable is increased by 1, which is right here at increased by 1, the value of the response variable is multiplied by b. So in this case, again, we keep talking about If this goes up by 1, that means you multiply 1 more. If it goes up by 2, you multiply twice. So in this case, let's take a look at the example. See, you multiply by b, all right? So number 3, use the following function to answer the question. A times 10 to the x power. Now think about it. When you have x equals 1, you times 10. If x times x to the second power, it times 2. So what is 10 to the second power? That's 10 times 10. So that's actually 100. So then let's look at the question. What happened to the output value if the input value increased from 20 to 21? So that means your x goes up by 1. And that's just 10 to the first power. That's just 10. That's from 20 to 21. The next question says from 30 to 32. Well, 30 to 32, that means the x is going to go up by 2. So 10 to the second power is actually 10 times 10. That's going to be 100. So what happened to the output value if the input value increased from 30 to 32? Well, that means multiply by 100 because 10 times 10 is 100. So that concludes the notes. Thank you so much for watching.